Okay, I should be live and audio should be there. Let's wait for audio to be here until I hear something in my headphone. Audio. Here. Yep, it works. This time we will talk about what's inside here. And this is my switch. So I do have a switch. And I think the idea of having a portable device is quite nice. The problem is that the controllers are really crappy. It makes sense that they are made so thin because you want to be able to carry it and not to take too much space. But holding in the hand, you see all the hole, the gap there is here. So I cannot support the device. So I have to this whole surface normally should be able to support the device. Now to hold the device, I have to press on the side and press on the back. And after sometimes it just gets crampy. And I do have something which I quite like. So this is the first issue. So when you see other controllers, for example, this is Xbox Squad controller. There you see that you have this kind of plastic here which really fits in your palm, and then you can hold on it. And this holds quite well. So I'm happy with it, although it's tiresome. So this is better. You have a better grip on it. The second thing that's not as good in here is that you always have to have your two hands close to each other and kind of support the remote. So you have some kind of power or strength in the arm so you can support the power. You could put it on the back, but you still have the hands close together. And I did have, or I still have it, actually a Wii. And the Wii is with the Wiimote. This is completely different, but I loved this split controller because you have two halves which are kind of independent. This is the usual controller where you put everything in here, and I really like the split controller. So it's split but with a cable, but it's a really long cable. And with the split controller you could have your hands, whoop, the USB just crashed while I was hitting on the floor. So let's restart OBS. And the stream should be back. Is the stream back? Yeah. At least it says that it is receiving excellent quality. So the stream is back. The problem was not my USB hub. The USB hub worked really quite well. The problem is, you can't see it, but here there is power for both these cameras. And the cable to it just dropped. It's actually, I didn't know, but it's pretty loose, so I need to figure out. But we are back. So what I wanted to say, on the Wii there was this split controller, which I really find quite nice because you could put your hands how you wished it. Sometimes with motion control, sure, you have to point to things, but else you just put your hands wherever you want. You could have any position. And I really like this concept of split controller. Now, there is a split, you can use this with split controller just by removing the remotes. So when you remove the remotes, very often you will have something like this, which just creates again a remote, but then you use the split controller. At least this time, you see, they figured out that that playing just with the flat section here is not a great idea, because they created a controller where they put some plastic here so you can have on the palm, and this is quite comfortable. It's a bit short. You see here, I don't have my tiny fingers, which are completely pressing against it. Although if I put it completely on the top, but I prefer putting this way because I have longer fingers. But it's meant for it's more meant for children, so I think it's okay. This one is quite longer. You see, it's closing. So I really like this fit. And what I want to do now is keep this idea of split controller, but have it in nunchucks. And also the other thing which I liked here is that you don't have left or right. I'm a lefty. Very often I play this way because now I'm used to having the. No, am I playing this way? I don't remember. It depends on the game and it depends on the task. Sometimes I'm playing this way. Most of the time I'm playing this way because on the left one I'm much more precise when it comes to control. And on the right I just press on the trigger and then I'm more powerful and faster because everything is made for right-handed. But sometimes I could play it this way, and I think most of the people are playing this way, where you have the control on the left. I don't know, it really depends. But on some games I played it this way, on other games I played it this way. And I like this symmetric design where you could have both of them. Sure, this is still left, this is right, but this is what you learn every time, so this doesn't change. I like this concept. With this, you can still play it split, but you cannot. So the first thing is it's really awful to hold in your hand when you play split. You can't last this long. You have almost no grip. You have some grip here, but this is kind of a sharp edge. They gave this thing up. So the controller came with these things, which I almost never. Is it this way? It seems to be this way, yeah, because this is bottom. So the edge are not sharp anymore, but it's still very awful to hold in your hands. You have to press on the side to keep it in your hands. You cannot let it rest here. So yeah, awful design. I could still kind of print something. Now this is stuck. I could still print something where you could slide and then it would have some plastic like that. But the other problem with this thing is that it's you cannot switch left or right. I cannot put this on the right and then play it. You see this, you cannot press on the button and on the button anymore. Yeah, so this is not really symmetric, and even if I could fix this side and have still a split controller, I wouldn't be able to put it symmetric. So what I wanted to do is take these joycons, so the switch controllers, and put it in this nunchuck, because so this has plenty of buttons and it's okay. Actually I could fit everything. No. We could put everything in there. Can you use the Wii controller on the Switch? It would be a good idea. I didn't check it. Let me check if you can. Wii controller on. I don't think so, because there are plenty of buttons which are not mapped. Can you use the Wii controller on Switch? How to use Wii controller on Switch? It seems you can. Okay, but difference between the key cone. There are seems that adapter. We have already answered it. I don't think you can. Simply because you don't have enough buttons. Some people doing something, so I would have a look to that into that. But you cannot do it straightforward. You probably have to mod it. I don't want to. Well, I could mod it. Actually, I will create a mod. Still, this is heavy, and I like this form factor. It's light and fits in the hand, and you have everything in there. So my idea was to put the internals of a Joy-Con into the nunchuck and have it left and right. So I have it on the left and on the right. You don't need the cable anymore because they have batteries, so we can remove the batteries. And this feels better than this. This is meant just more for pointing, but could be not. Actually, could not be a bad idea to put it inside here, though. But you don't have the second trigger button. You only have 2 buttons. It's not ideal. I still want to put everything in here, and there is still the questions of these buttons, which are here. So you have the 2 buttons there. It's not meant to play left and right. So this allows you to have a full controller with left and right, but it doesn't make a difference. It could be this left and this right, where you can play with the 4 buttons here. So you have 2 controllers instead of 1. Here we still want to use both controllers, although we could put everything on 1, but there are not a lot of games which can be played with 1, and then it doesn't work. It wouldn't work with that. Yep. So we will still have 2 nunchucks, 1 for left, 1 for right. And have to fit the things inside. And then we have a split controller, which is for lefty and right. So you could have put it on the left and or the right as you wish it. Because it will still be symmetric, and it feels quite good in the hand. And I don't have to, I could reprint this plastic. We'll see. For now, I will just take apart one of these because I don't play, I have 4 of them and I don't play that often anymore, and not with 3 additional friends. So I can safely take one apart. I will not take the original one. So this is the original Nintendo one, which is quite good. I will take apart the crappy one. Oh, also other adapters. So for the Switch, you don't have to use Joy-Con. You could use the Joy-Con with that, and it's quite fine. But you can have external controllers. This is not too bad, but again, it's not a split fashion. And after some time, so ideally, I would have it this way for me. So you see, this is fitting quite well, but the pads on the palm are not fitting inside it. There would be need to be a bit larger. So this feels still a bit stressing, and after a couple of hours, it's not nice to feel in the hand. There are also these things where you see that you could play as a controller if you have multiplayer, and with some games you can play this way. But this is really not comfortable, so they have these adapters where you place the controller here, and again you have this palm ball, I don't know how it's called, the thing which ends in palm, and this is nice. It's still a bit short for me, but it's a lot nicer than just that. But we will still have two Joy-Cons, which we will fit. At least we will fit one in these. So let's open the Joy-Cons, and because the Joy-Cons are a bit more expensive, I will not use the Joy-Con, but I got, at least for the prototype, afterwards if it works we can still play with that, but for the prototype I bought these, very inexpensive, and this seems to be buggy, or maybe it presses on the button. We'll take apart these. I'm not afraid of destroying that. I still want to keep these so I can play with it. So we don't need this anymore. Actually, we do need the Switch so I can test the controllers. I don't need this. We don't need this. This is gone. Let's make a bit of space on the table. We don't need the overview camera for now. No, although we leave it there. You're used to it. We don't need these, so let's test if it works. And this is, you see, it's a knockoff. It's not as nice, and it's already broke once, so not afraid of that. I don't have only genuine controllers. So this no-name thing took it because it's inexpensive. Joy-Con, I think I paid 20 euros for that. Oh, it comes with a cable to charge them. 1 USB-A, 2 USB-C. This is the first time I saw the 2 USB-C. Nice. It's another kind of cable I can put on my USB cable tester. This Joy-Con has an issue. Let me switch on this thing up and go to the controller menu and see if they are detected. Controllers. Okay, so here you have the controllers. Let's zoom a lot more up. So they are detected as wireless now using Bluetooth. If I put this in, oh, it is detected. It has no power. So let's charge it a tiny bit. And that I didn't know. It knows the color. I thought gray was the standard color just for any remote, but no, the remote can tell its color. And the other side, it works. Okay, so it can tell color. We need to charge this one. Does it work if I normally if I disconnect it, it then tries to connect over Bluetooth? Yep, this works. The other one, no battery, it just died. Let's put some battery. Okay, this remote has a connection issue. It has a Bluetooth connection issue. It cannot connect over Bluetooth. Okay, so, well, I didn't pay a lot, but still, I expected this to kind of work. I have no idea. So do we want to take this one apart, the broken one, or do we want to take... No, the broken one, we don't want to take it apart. We will take the main remote on the right apart, because this one will get exchanged under warranty. I just got these a few days ago. Up. So let me get a screwdriver, which is the small screwdriver. Where did I put it? I moved it. I never know the color. This one. Up. Yeah, this one still is showing right, left, right, left. It's trying to connect, but it's not managing the connection. Let's switch this off, and this should switch off. Yep, it does. The other one is broken. Still like, maybe it's just, I'll still like to open it to see what's inside, how broken it is. We will still do it. Let's let it charge a tiny bit. Let's see what's inside the joycon. No, this is not the right screwdriver. It doesn't fit. This should be the right one. Up. Okay, yeah, this one fits, and I can turn the screws. It feels so light and crappy, but I am only interested in electronics. And here they did it a bit better. See, Joy-Con, this, it feels better. You still have the sharp edges here, which is a pain, but it still feels better. Yeah, there are plenty of designs which I don't understand, Switch made. Like these controllers, you can't put it in the hand, it's a pain. Having the charging port at the bottom, seriously? You have the headphone here, and then if you want to charge when you're playing longer, you have the charging port at the bottom. This is stupid, and this crappy little thing which holds nothing. So if it's really perfectly flat, but then as soon as you touch it, closes. This is really, yeah. Usability, no, they are not usability friendly at all. Oh, accessible. I don't know what they were thinking. Still, it's not a bad console, and I like it's at least they have something unique, and it's not just a PC with a controller. Okay, so it's not only the screws, there are some tabs or some clips. Let's get the D-clipper. Let's see what's inside. While this one all the time roaming until searching, doesn't it end? It has a real issue. Okay, one of the clips just got loose. Okay, okay. Oh. Up. There were 4 screws. Yeah, here's the last one. Let's put it in this box. 3, 4. I don't need this. And let's see what's... Oh, oop. There goes a spring. So it's... Okay, there was the spring. Wow. How did it... How was it holding? Let's switch some lights. Come on, light. Come on. Light on. So this presses directly here. And you had a spring without any retainer. It's here. Does it go inside there? Yes, it goes. Wow. Well, it's built down to a price. Are these the same screws? No, they are shorter. 1, 2. This is actually just, I know it has buttons also, but I don't care about the buttons. I probably care about the lights. And this is the connector to this, so you can pair with it. I'll not use it at all. My joycons won't be connected. Up. So we can leave it here. These are the 2 buttons. So here, yeah, we have 3 buttons. 3 buttons? Why do I have 3 buttons? The sync. This is the sync button. Okay, we have 3 buttons. 1, 2, and the third one is there. And how was this holding? In here, just pressing. Okay, this will never hold for a long time. Ooh. Yeah, built down to a price. Let's zoom a tiny bit more up. So we have the battery, which is not that big. It's 300 milliamps, milliamp hours. Would have expected a bit more. We have don't think this is a microcontroller. I would guess this is a I/O expander. I don't know. We will have a look. And they scrubbed off the marking. They did. But we have plenty of test points. And we even have RX and TX. So we could have serial out of there. And you put the... Oh, wow. It's really cheaply made. They have the cable under the stick pressed strongly against. I don't think this is how this is meant to be. This is the analog joystick. Oh, it's not a flat one. And they need the space, the bigger space, because these are really flat. This is a classical one, which is on a separate board. How do they connect the board with, let's check, with pin header? Ideal, because this means, you see, so these are the joysticks. You can have them a bit different, but these are just 2 potentiometers. And the potentiometer is just a metal piece. There is a ring, a carbon ring on the outside, which has a resistance, very often 10 kilo ohm. We will check what the resistance of this one is. So you have 3 pins. The outside are the complete resistance, the whole resistance, the whole track, 5 kilo ohm. Okay, 4.5. And then on the middle, there is a wiper, a metal wiper, which just presses on along the track of the carbon film. And this is at 4. If I move it, we have 5, 0. And if I go on the other side, we should have something like that. So yeah, if you press on one side, but you cannot completely turn it, so it doesn't completely work. So yeah, if you press on one side, you have the complete full resistance. If you press on the other side, you have 0. This is how they work. Why is there stick drift? This is the most precision. So when you do this, you wipe against the carbon film and it just tears apart with time. Sometimes the carbon film has a bit better quality and it holds a little longer. Sometimes it doesn't. So it means that this section, the carbon film under this section, gets used and then it makes wrong contact and there is stick drift. It doesn't know if it's really in the center or somewhere else. There are solutions against stick drift. Either just replace the joystick, which I already did for this one. This is not the original joystick. It has a stick drift. It had stick drift, or use other technologies. The N64 used encoders, so when you pressed, it just encode how much you pressed. It doesn't give an absolute reference. It just gives relative movements. And the last one I know of are Hall effect sensors, but I don't think I've ever seen Hall effect sensors. But the Hall effect sensor is just you have a magnet here, and when you are moving, you have a Hall effect sensor here which detects magnetic fields, and when you're moving on this side, you are closer, so the magnetic field is stronger, and if you move further away, the magnetic field is weaker, and this way you can also measure the distance. And this doesn't wear at all. So the optical encoder and the other thing don't wear. Why do they use this? If it's crappy, it's simply because it's very, very easy, because you just measure with an IDC. You don't have like an optical encoder. You would have to measure the pulses. Here you just measure with an ADC, which every microcontroller has, and it's extremely cheap. That's it. If you want something which works better, then you would have, oh, I forgot about this. This will be a pain. If you want something which works better, you would have to put a bit more money. I don't know. Probably someone does better remote control with Hall effect sensors. Here it's only, we will have a look at this. I think this is also just Hall effect sensor. But this is only potentiometers. But what is good is that we have the 5 connections here. Why 5? We have 2 of them. We have a common ground. We have a common plus, which is on the 10 kilo ohm. So we have 1, 2, then 3, 4. These are the 2 potentiometers. And the 5th one is this clicky button here, because you can press on it. And this is something which is not here. So I don't know how I'll do that. Maybe I'll just put this controller inside. Yeah, let's just put this part, because you can move it around. Let's put this part around here. Just it needs to be. So this is good. This is removable. We will reuse this not for the buttons, but for the LEDs, so we know if it's connected or not. I will probably, I don't know how we'll make it. I don't want it to be in the way. And I'll probably have 4 LEDs on top, 5 LEDs on top, which indicates which LED you are, which controller you are. But maybe then it's annoying because you always see it. On the side, you don't see it. Can I put it somewhere where it's not in the hand and where you can still see if it's working or not? There's not a lot of space. Here it's really too bright. I don't want it to be shining and strong. I could make it a lot dimmer by changing the resistor, which they don't have. So the resistor are not even on this board. They are somewhere here. Okay, so here we have plenty of test points. Let's take it completely apart. So the 2 buttons here, there are 2 buttons, and again there is a board. So I can just remove this board and take these 2 buttons. So I like this. I think this is more integrated in the other one. So for modding, that's ideal. Here we have the vibration motor. There was no vibration motor here. That's fine. And here we have the other. Oh, here we have the other controller, the battery. We can remove it. What I was surprised about is here there is a button inside. Why would there be a button inside? Does it map to anything? Is it a reset button? It maps to this tiny hole just here. So this is very probably a reset button. Here we have one microcontroller. This is very probably an I/O expander. Oh, you have 2 actually. Wow. I would guess this is a shift register or an I/O expander. Though the marking has been removed. But this is big. Or maybe a charging? No, it's not that big. At least we have plenty of test points, so we can connect also to this test points if we want to. Here we have another IC. It's written AC IC2530. I don't know what this is. We need some kind of charging controller. IC2530, it's in QFN. 2530. What is this? Basic data, pair of galaxy, Q. Let's see for QFN. This is something else. Dual row quad flatback. That's his design guidelines. No, I want the chip. I don't want about QFN. I know what QFN is. Up. Sign in. Let me check in my database if I have something. Let me share the screen. Full screen. Yep. So I need this to be inside. So we put it there. This pair galaxy in pairs of galaxy. What's this? Something completely different. Here part 2530. To have something. Parts remaining, it's still loading. Yeah, it's loading the database. No, this is, I presented in one of my videos. I collected, oh, it's 1 year ago. I stopped 1 year ago. I collected a lot of chips, which, it's QFN. It's loading. I collected a lot of chip definition, and it allows me to identify circuits. Just go ICID, you will have more info if you want here. It is pretty slow, but it's my server. It's not meant here. CC2530. Okay, but I don't think this is, although maybe do they use that? They could use it. Select parts. It should select part variant. There are plenty of variants. With how many pins does it have? It has 5 and 3. So it's not this one. And these are the same one. So let's check this. No, not the same, not the same. The pinout doesn't work. The pin. No, no, they're all the same. No, it has 5 pins on the sides and 3 pins on top and bottom. So that's not this part. I don't know what this chip is. U6. It's I2C. I would think it's a simple microcontroller which does the shift register and talks I2C back to the main controller. Let's switch back. But it's not too important. We will just use it. I was just interested. And what it would be. Actually, I can switch to the other camera. You probably have a better view. This doesn't work. Other camera doesn't show anything. This camera. How about you show something? Okay, now the switch died. Damn it. Okay, input 2. Why don't you show anything? It's because it's 4K. We don't want 4K, we want Full HD. And this works now. Okay. So now you can have a better view. And me too. So that's inside the controller. And it doesn't make an autofocus. So I will have to make the focus all the time. And we see plenty of glare. So this, for me, it's a shift register to read, to speak to all the. So here was the cable connection. It's a stupid idea actually. Let's switch back to the other camera. Okay, so we had this ribbon. We don't need this anymore. This is still searching, so this is in a weird mode. I will maybe press on the reset button. Okay, now it's reset. I hope it is still charging, and it's still. Why is it doing that? Why? When after you charge, it just. We will take this one apart also. Why is it trying to find something after we press on reset? This is a stupid controller. We'll have a look. But we see that here they have an embedded antenna. So this controller also has an embedded antenna. I would be surprised that they would be a bit different. Here we have a tiny microcontroller. We can zoom a bit better. Tiny microcontroller, I think this one just interfaces with this I/O multiplexer or shift register and forwards everything to the main microcontroller, and this main microcontroller has the antenna for the Bluetooth. And here we have probably, this diode next to transistor indicates this is the motor driver. So you remove the spikes and we can remove this. So yeah, here you have 3 buttons and 4 LEDs, and I think this I/O expander is probably to also talk with all these things, with this and with this, and then just forwards it. That would be my guess. So let's remove the board. It's still another screw. 3 different screws. Very efficient design. And I didn't look at the other microcontroller. The other microcontroller has only, so it speaks Bluetooth, that's for sure. And it's marked that's only one marking, UG3768. Let's see if I find something. UG3768, but there are so many controls. It might be an ASIC. That's totally possible. I'll probably find nothing on it. QFN. Yeah, I know what quad flag is. Come on. I want this inside. No. No, there's nothing. I think it's a dedicated. There are so many microcontrollers, dedicated microcontrollers now. It's probably just a cheap thing which works, but we know microcontroller because there's a crystal also. And where do we have the charge? So let's remove this. Let's see if we have something on the side. Here we have the other buttons, home and turbo. This is probably the, what is this? U3. I wonder what it is. And how the buttons are done. The buttons are just like you find very often, tactile domes. So how does it work? Here you see you see 2 carbon pads. These 2 are not connected unless you press the button, this button, which has also carbon inside, so it makes contact. And this is cheap to make. It doesn't the way you make the plastic just makes it good or not. But the advantage is that we have the buttons all here, so we could actually map the buttons to other buttons on the outside. We don't have to use these buttons, and we probably won't use these buttons. We will have, I don't have tactile buttons, I have 6mm buttons, like the one which was here. This is a 6mm button, and it's a mechanical button, and you hear the click, and you can really feel it. This controller we'll just take it apart afterwards, but let's finish with this one. This, I don't know what it is. Ah, that's very probably no, I don't know. I would guess it doesn't have a lot of capacitors on the side. So this is USB charging, which is really good because here I wouldn't be able to charge over USB. You charge over these ports when they're connected. Here I can charge over USB, which is perfect. I can fit USB here and I can deport the USB if needed. One must be, no, it doesn't, it's not must, but could be LDO if it's not integrated there, because we find plenty with integrated, but one should be a charger for the battery. Here, you need to charge the battery correctly. I've seen microcontrollers where the charger is in the microcontroller. So they have fuel gauge, LDO, and charger in the microcontroller, which is pretty awesome. Maybe this one has it. No, this is the transistor. One of these could be a charger. This is 65B16. 65B10F. B10F. What is this? It's a color. I see. It's a SOT. RF transceiver. Ah, makes sense. Might it be this? It's in SOT package. So what could it be? No, that's not that. I don't know what it is. I would think that this could it be? No, it's not. They would have. So this is directly connected to this microcontroller. This Bluetooth. So I don't know what this is, and I don't care. Yeah, there are plenty of ICs there. So this is this side, and then we just have the buttons. Do they make the buttons so we cannot mix them? I'm not sure. Yeah, they have you see the large tab is on this side here, the large tab is here, and then you don't have all the time 80 degrees, and this is for so the operator don't mix the buttons, because you cannot put this button here. Not possible. It's a nice trick for avoiding errors. Okay. And then we have the two buttons. Ah, and here they have tactile buttons. Why didn't put some domes? Maybe it's more expensive. That maybe they wanted smaller buttons, and these two buttons are different. I don't know why they did that. Here's the small motor, and this motor just has a weight inside it, and I can't remove it because it's stuck to the case. I don't want to rip it off. Flat. Okay, there it is. We don't need the case at all. We only need this, and this will never fit in here. Nope. I didn't think about that. That it's so large that it won't be able to fit. Still, we'll try. We'll see if it works. I also thought about designing my own circuit board, but it's too much effort, and this controller was pretty inexpensive. We might still have issues. We could cut the traces and have it 2 parts. That's still possible. It's some effort, but it's possible. Let's have a look at this one. I'll put it on the side. This is the right one. Let's have a look at the left one, which is completely buggy. It's probably very similar. So we still have the 2 tabs on the side here. Did we have? Oh, we. Okay, 1 and 2. Yeah, it's almost identical. Smells nice, and you see how crude they didn't clean at all the soldering here. You have so much flux. Ugh. Ugh. Horrible. So let's remove. You have so much flux that it's actually spread on the screws. Okay. So why can't you find? You can't find the device because it's there. If I now. No, it doesn't find. Okay, I won't be able to use this. This controller is dead. But it's probably the very... here was the spring. Now I get it. The spring is right there. And it was for the bottom one. Here we again have this stick controller. Why can't you connect? Here everything they even... it's so crude. Yeah, it's the same, almost the same architecture. Here they have something different. They have an additional IC. This one? No, it's the same. Because the buttons are here. And you see, you have this on the side again. Oh, they put the antenna pretty far away. It might be. So this might be the reason why it can't connect. No, this is something else. This. Do we want to try to connect it? So let's try. Let's try to connect and see if it still works. So this controller has an issue. Okay, now it's not even detected when I plug it in. So this controller really has an issue. And I didn't disconnect that. No, that should work. Let's press on the reset. Now it's detected and now it's charging. If I remove it, will it detect it? Can I remove it? Yes, I can. Done. No, it doesn't detect it. Up. Yeah, so this controller is dead. I'm not sure if the firmware, if the Bluetooth, I don't know. But definitely dead. There is a decoupling capacitor. Does it heat up? The microcontroller is the same, and the architecture are the same. So I'll get a new one. But yeah, it can't connect. I don't know why. It is paired, but it can't connect. And it has some power. It has enough. It should have enough power to have a Bluetooth connection. Okay, detected. It's charging. And if I unconnect it, up. Oh, now it works. So it just needs a lot of power. Now it is detected. You see, here it says that the left one is detected. It's just very intermittent. Why is this blinking instead of just being on all the time? I don't know. Was it the same way here? Where's the battery? Here is the battery. And let's try to press a button to see if it can connect. Yes, it can connect. Why does it say that this is 2? This should be, and this is now disconnected. Okay, this is really buggy. This is connected, I don't care. Yeah, this is really, really buggy. If I press, let's put it again. It works when it's, so everything works when it is connected. It's just the Bluetooth that's crappy. It's not just a power issue because we're all the time connected here. And here it tries to scan and it's not managing to connect. This firmware has an issue. Let's see if by pressing long enough the reset button it makes something. No, it's just a general reset button. And it's not even that, because if I press on it, it doesn't keep on the reset. It turns. And it's not connecting. So this is, I don't know, it's a user button which they configured as reset. Oh, and it takes so long to be connected and to be detected. It has this Bluetooth routine probably, and it's not done with the Bluetooth routine, so it doesn't check if it's connected over USB. Yeah, the programming on this microcontroller is less than good. It's not, no, it's not finding. Come on, reset. Okay, I had to press reset. Now the battery is full. It wouldn't be able to charge the battery in 20 minutes. There's, yep, this microcontroller is dead. Or this microcontroller, this remote is dead. So let's not have a look at it. Let's send it back to warranty once I've closed it, which won't be as easy as I say. Let's put everything here and this will go back. And it's only a proof of concept. I mean, I wouldn't have lost a lot of money if it's not working. So let's have a look at inside here. Oh, triangle screws. Nintendo. Do I have this? I should have this bit somewhere, but I don't know if I have it that deep. Triangle. Does it fit in here? Oh, it does. It could work. I also have a... Oh, it's not long enough. I did have this triangle thing. But it's not a Nintendo. and this is not the right one, and it's not triangle, but it's not Nintendo who made this controller. This is a ripoff. Why would they want to use a triangle one? I know I have triangles. I just have to find it in my bit assortment. No, 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 no. And I know I have actually not just. That's not triangle. 3 wings. I know I had one. Apple, apple, triangle, but not the right triangle. Would it still work? Okay, it might still work. Fine. I have a screwdriver for that. I'm sure I won't find it again. Damn it. And here. Oh, it fits completely inside. Let's zoom out so you can see something. Yep, that's. And this is also triangle. So I need to find a screwdriver. Or I need to force the screws, one of both. But just a bit won't do the job. And in my collection of screwdrivers, no, this is not triangle. No, 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 no. And the special screwdrivers. Where could I have put them? Ah, I gave it to someone. I remember. I gave my Nintendo DS set to someone, so I'm sure I don't have these screws anymore. These screwdrivers. Let me check, but I'm pretty sure I don't have any more. Yeah. Yep. Yep. Yeah, I gave it away. I need to order new ones. For now, let's just force the screws with another screwdriver. This will break my screwdriver. What would not break my screwdrivers? Ah, I have the other screw bits. Problem here is that it's too long. No. A small triangle that would fit better, but I don't. It still is probably too long. Yep. Yeah, I need a proper screwdriver. I could remove this one, but not the other one. Not even this one. How did I? No, I didn't. I just soldered the cable without opening it. And I had the screwdriver before. It's just that I gave it away while I was clearing out my stuff. Let's take a sturdy screwdriver and try to take it out with it. And this is not even long enough. What's holding me back to... Oh, this mod is just a stupid screwdriver. That's such a shame. Also because I had them in the past. I could melt them. Not sure if it's a good idea. Nope. 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 No screwdriver will make it work. I need the screwdriver. Proper Nintendo screwdriver. But I'm sure I gave it away. I'm pretty sure of it. I gave it away with the DS, which needed these screws. Makes sense that I don't have it anymore. As you can see, I like Nintendo consoles. And I think the DS is quite good. Plenty of games to split screen. It was a good idea, and there were some with the touch and then the button. Can recommend it. Still good consoles. I think it's not made anymore. So let's try to have these screws removed without the right screwdriver. What about a flat screwdriver? Maybe a flat will be good enough. Maybe. Or maybe I'm just breaking my bits. I think this one. Yeah, this one should come out. No, it was just pretending. Oh, I got one out. So it does work. Here I'm just throwing the plastic. Maybe they put the screws just to look genuine. That's possible. Expensive, but possible. So I don't know how expensive these screws are. Come on. Second screw. I'd love for you to get loose. Up. No, I don't have. Let's try. So I have not a lot to talk about while doing that. It's a shame. We had one, but we don't have the other one. Oh, maybe we do. That is the right bit. And if it's not completely going in, so there it is. It should be okay. Maybe it's unscrewed and I just need to open it. Where is my spatula? Here. Yeah. Second screw is now also gone. So it did work. Up. And these screws go immediately to the bin. Okay. So how did this work? I just know this is speaking I2C, sorry. I2S is for audio. So there must be a controller with just these two buttons and then this thing. Yeah, here are the two buttons and we could even copy paste. Ah, no, not the same. But we have the three connections here. So we can reuse that. And here, this is, so we have the two buttons. Here we have the, so here there are potentiometers again. And here is this blob. So this talks I2C. I don't know. Ah, it has a gyroscope. I forgot about that. It has a kind of a gyroscope. I don't know. At least a motion sensor. I think this is the gyroscope. It's for finding out when it turns, when you are shaking the controller or if you're doing this. And I wanted to keep this here. Maybe so this is, yeah. This is very probably in QFN, the gyroscope. This is very probably gyroscope. If not, it's this, but I would probably guess it's this one. Does it have a gyroscope? I think so. Can I check it? Search for controllers, close. Let's see if I can check it. Controllers. Controller vibration, controller update, motion control. I need to first press on a button on this one so it connects. Home. Okay, it is connected. It vibrated and it is detected. Calibrate controller. Hold plus. It's this one. I can't press on the button, so I can't control. But yeah, this has a motion controller, and the other one has it too. But probably, I would guess it's this one. Yeah, makes sense. So this has no way it can fit inside here. we can replace, at least what we can do is, where is this? This assembly can replace with this stick. So it's even a bit flatter. Can we do it in situ? Up. Almost. With a bit of glue, it would work. I'm not sure if it's the right orientation, but oh, the height also is different. We can cut the plastic. Here we can cut the plastic. Let's just have it this way to test. It's not perfect, but does work for a prototype. That's good enough. You see the button. So you have plenty of range. Yeah, with chewing a bit of plastic and putting hot glue, that works. So this is one of the things. Now we need to fit this inside here. And that's not possible. It's just too large. What we could do is have both. So cut it here, check, cut it here, and have these two stacked together and put on the bottom here. That would work. What is this button again? What is this button? K8. It's plus. So I can press on plus and put the sensor. Remove any straps, put the controller facing up, stick facing up. Okay. Does it detect? Calibration complete. So yeah, it has motion control. Up. So this saves some space. The battery, we can put him on the bottom. We can put it on the bottom here. Yeah, there's place for the battery. There will be also, we will stick the motor on this plastic. Let's zoom a tiny bit more. We'll put the motor on this plastic. We'll have the battery. We need to deport the USB connector to have it on the bottom. Could have it now. Don't put it on the side because it will be matted. This we can remove. Up. Yeah, so we will have a deported connector here. We'll just have wires going through these pins. Is it detected as something USB? Let me check. No. I just connected to my computer and it doesn't say anything about any USB. So this is just for power. For power, they use 16 pins. Generally, you use 6 pins if you only want power and not 16 pins USB-C connector. But maybe there's a special mode if we press and reset and press it in. No, it doesn't have a USB. And do we see the tracers? Actually, no, these are the CC tracers. No, these are not the CC tracers. There is USB. If you look at, now we can take this camera, which is better suited. If we look at, let's put it there. Zoom. If we look here, when you have two traces like this is USB, so there is USB somewhere. So there is a secret way to reprogram this microcontroller. These two resistors, so you only need 2 resistors for CC. Oh, no, they cheated. They only have 1 resistor. Maybe this is what they're doing. But it's not, it's a bit too central and they have a second one. I don't know what they did. I would have to look. So it's 1, 2, and 3, right? 1, 2, 3. What's the third connection? Let's have a data sheet of a micro USB connector, and let's have a look at the data sheet. I have plenty. From one of my projects, I use this connector very often. Projects. This one uses it. I'm sure I don't have the data sheet for that. Data, doc, data sheet. Connector, USB, is it this one? This is, no, this is a 24 pin. This is a 24 pin. So no. Let's just take a project with the footprint. Project. This one has a board. Let's open the board. PCB. So 1, 2, 3. Yeah, it's D plus. Yeah, this is D plus. You let me show you. So on the screen. Up. And this we don't need anymore. Here you see these are the two power pads. So one is ground, one is, so there are 2 pins on here actually, but they are so close together that this is one pad. Then we have the V-bus, so ground V-bus. Don't forget to connect ground to shield. Then we have the CC wires. Here we need a 5.1 kilo ohm resistor pulled low, so it actually provides power. Does this have it? It doesn't seem to have it, but it should. Maybe they are on the bottom. Here. These are the two, and if we measure it, we probably will find that these are 5.1 kilo ohm resistors. Let's have a look. And you won't have a look because you are on the, you don't see the DMM. This is because it's green. Can I put the DMM also here? Wait. I don't care about that. Let's add, it's image, right? Image, existing DMM, okay. And let's put it here. So now you see. Up, and let's measure them and open. 5. So it's 5.1 kilo ohm resistors, and this indicates that we are looking, this is pulling down. So here there is actually USB. These wires are USB, but let me check if it's just because I'm not connected it to power. Let me connect it to another USB and see if my computer detects it. Maybe it's detected like an HID. No. I think there must be a special button combination to have the USB enabled. Else they wouldn't be putting traces on there. But there are also some resistors which are not connected. These are not the right ones. So these resistors are connected. Yeah, I don't really care. I will not use USB. Let's switch back to the other camera. So this is what we see when you have 2 traces together. It's very often because, like you see here, it's very often because USB-C doesn't matter on the orientation. So the USB 2 data lines, D plus and D minus, are on both sides of the connector, and you connect them on the receptacle together. So you have the 2 lines, and this is how I identified that it has USB. And you do the same inside. So let's switch back to the bench and Let's switch back to the other camera. Up. So this will be deported. Will this fit? We can break this plastic, but it still has a huge button, which we need to press. The Z button, which is not fitting anymore because it's probably upside down. The Z button here. We still need to be able to press it. Can we put it in height? No. Okay. I'll do another way. No, I can't. We could have it external, so connected with ribbon cables to this connector, but then we don't have the motion control anymore. I don't use that. Not a lot of games are using the motion control. It would be a solution though. Not using this I2C, but we just have the buttons on here, just some cables, and then going out to this board on the side. It's not ideal. I would love it to put it here, but there's not enough space. I can't put it in. Oh, I could. If I cut completely this, it could fit. Oh, that's a lot of trimming. Ideally, I would design my own board which fits inside here. But I don't know. Maybe there's a project which simulates Wii Joy-Cons. I'm not aware of them. With a Bluetooth controller. Maybe somebody already looked at it. Then I would probably design my board and have it fit inside here. It would be a lot more expensive because you need the motion controller, you need the buttons, you need the potentiometer. So it's more than what I did for that, and the charger and so on, but it would at least fit. Let's make it fit. Let's just try to make it fit. This is not important. Let's remove everything which is inside here. Will it complain if I don't have the buttons? This is a good question because I will cut the board right there. Tuck, tuck. We will have flying wires or FPC. We could have an FPC connected, so flat flex cable, or just wires. There are not that many wires. We can scrape them. Yep. This would make a lot of space, and we could almost fit both of them. So let's first remove this thing. Actually, this was supporting, yeah, but we don't care because we will glue it in place. Up. This is for the rigidity. We don't want it. We want space. But this is for the screw. We will still have the screw. We will keep this screw. We could just glue it together without screw, but now let's try to make it with screw. Let's remove the battery. The battery can be deported. Yeah, we could fit it. It will be tight, but I think we can fit it. Up. Would be surprised if it still works after I cut it, but maybe it will. Up, and designing a board makes sense if I make plenty of them, but this is just my need. I'm not sure if everyone wants a nunchuck con. A joycon? I don't know how we'll call it. I'm open to ideas. So, up. Most of the plastic is gone. Okay. This will be an issue. Can it work without the battery? Because I'll cut it here, meaning the battery is connected here. It won't, the main microcontroller, which was the USB, won't be able to connect it. So does it work? Okay, back. Controllers, no. Back, controllers. Let's see if I can connect to the console just with USB. Yeah, just with USB it connects. And yeah, it makes sound when I press on the bottom. So that works. Now, what does it actually here? It should connect. Button. Come on. You did work. This is reset, sorry. Home. You don't work anymore. Maybe when I pressed on reset, it lost the connection. No, it's just a reset. I don't think it clears the memory. But here is not the right screwdriver. Yep, this one. Maybe have to repair it. So we just need this. It goes in here. Come on, Flatflex, go in. Zoom a tiny bit. Okay. There's still a screw. If I pair it. It has issue with the battery. Now it is paired. I don't have the button. Right away. Okay. And now you should be able to connect. Press on a button. Close these buttons. It put the battery. It did work once. Now it is. Just doesn't know if it's charging or not, but it is connected. And it works without. So now let's try it again. Disconnected. Let me. Here. Leave it connected. Okay, this works. If I press on the button. Does it work if I press on the home button? Wake up. Try to connect. Home. turbo. Does it have to be of A, B button? Come on. Ah, we can still put the other. Where is the lighting thing? Here. We can see if it tries to scan. This way? Yeah, probably this way. So one is upside, the other is facing down. Okay. Ah, it tries to charge all the time, and this is probably what it's telling, that I'm trying to charge. Up. Brief blink. Yep. It's shutting off, on and off. And it's not trying to connect. So it did work once, but this was just luck. If the battery is not there, it won't work. What do we want to do? What do we want? Is this just a 2-layer board? Yes, it seems like it. Pretty sure the joycon has more than just 2 layers, but this one has only 2 layers. So, if I put the battery, it should work. Let's put the battery up. Now connect. Yeah, blink first. Oh, blinks mean I have no memory. I'm not paired. What does blink mean? Okay, no, it just means it's the level of the thing. Now it's connected. And if I disconnect it, it won't pair because it's not capable of working without a battery. Poor design, but I mean, you had a battery, so you don't need to. Oh no, it does. It's just that not all of the buttons, so this works, but if I press home, home is not a button. Oh, it is. It works without the battery. Let's try again. Off, on, keep pressing home for 3 seconds. For a couple of seconds, we see the whiz, and we see it connects. Now we will butcher the thing, and we will try so we can fit it in here. Oh. Will we be able to? We'll see. So let me take the butcher tool. Up. It's time to die. What's KRB? There are so many. Where do I have to cut it? Can I leave a tiny bit here? Yep, okay. And clack, gone. That's one side. Now the other side. Up. Now the 2 sides are gone. Let's see if it still can connect. Press on the home button. I would expect it not to. No. Yeah, as expected, it's doesn't like to be cut off. Meh. Okay, so home. Let's try again, just the last time. Maybe what happens if I put it in here? Let's remove this. Oh, no, it just saw that. No, it doesn't switch on. It knows there's an issue. Up. So it needs other cable, but for now we just want to find out, can we put it inside the joycon? Else I have a printer, so I can still print something which is bigger, where this would fit in, but for now the mod is about fitting this thing in. So here we have power. I need to pay attention to this. MB motor A, yeah, we don't care the polarity of the motor, right? Well, let's still mark it. So that's black. That's black. Let's remove the motor. Up. We have to cut this. I hope this doesn't change the impedance of the antenna. No, it doesn't. Okay, we cut this corner. Can we put inside? Almost. Let's move these pillars up. We also want to remove the USB. Here we even have a 5-volt pin, so we can directly solder to that. I love that there are so many points. So we will try to cut this completely away without cutting the crystal. Then it's still very tight. Sideways? No. This way? It could work. Yes, it could. Oh. Let's remove it without cutting the crystal. Okay. USB is gone. And it almost fits. We don't care about the direction, so we could fit it any way we want. Actually, we have to remove this pillar. It's just too large and it will give us a lot. Will give us plenty of space. It will remove rigidity, but nothing that a glue gun wouldn't be able to fix. So let's remove that. Oh, maybe they did it in the Joy-Con. You could still say that it's left. Yeah, possible. Don't know if they did it. So now, does it fit? Yes, it does fit. fits well enough. Oh, you see, electronics is inside. Still have the button, the Z button, the other way around, which we need somehow to have a press mechanism, but that's completely doable. We just have to retake this part. Let's unsolder these buttons, this connector, or this one, maybe this one is probably better. Let's unsolder this one first. We can still unsolder the other one. How did it go? I don't remember. I think it was held it this way, so this was on the bottom. And this makes kind of sense. Yep. There was no... this way maybe? No, it's still this way. You stay here. Yeah. This way we have locks. Yep, and it springs. Yeah, we will keep this assembly, so we can put it there. Yeah, this cable will be too short. This needs to go here. This needs to replace that. We also have to trim this board, and we can trim this board a lot, so it fits here. What was this again? This is the plus button. But it's probably only connecting to ground, right? So we can remove it to save space. Nope, that's not a probe, that's a probe. Is this side ground? Ground. Yep, this side is ground. So only the trace is important, and actually the trace goes probably to one of these test points. So we can cut all this part away. And we will. Up. Up. Let's unsolder it first on this side. That's unsoldered. Up. Up. This, so we put the two buttons. Yep, right. And no, wrong side. Here. This fits in. This is why we had the supports and so on, but we can glue it. Yep, this still works. So it was inside this way, and we'll probably have to glue it. So we have the two buttons. We will have this stick, which will be glued inside here. We just have to be prepared. What is top, bottom? Up. It was this way, this way, this way. So this is bottom, this is top. Actually, do we care? Yeah, we do care. The middle button is, yeah, we care. So this is up. So it means that we need to put this way. This is up, right? Is it? Let me check again. So it goes this way. It means that it is connected this way. This is up. This is up. Let's mark it. Where's my pen? Here. Up. If we glue it inside here, we still have access to all the pins. Up. Right on the bottom, and then we can put the wires up to this thing here. I can even desolder it. Ah, it's even marked. This is good. RX and so on. So this is quite good. Okay. Solder removed. Header removed. So we save a tiny bit of space. We have all the marking, ground, R3, VCC. R3, that's probably the button. This button here. Click, click. Do we want to warm up the glue gun now so we can already fix some? Yeah, I'll warm up the glue gun. Glue gun. Up. Power. This. The click is not ideal, but it's a proof of concept. Yeah, the click doesn't sound nice at all. It doesn't also fit completely. Ugh. It feels some doesn't spring back. Means the connection is not because no, I removed that. This was going to the side. Maybe it's better if it goes to the side. Maybe it's better if I have long cables going to it. Let's solder some long cables to it. Yep. Let's remove these ones. And let's solder cables. Let's take fine ones. Up, 1, 2, 3 colors. This and this. This way we can already have long cables for these pins. So let's keep note what we are doing. Up, up. The two buttons. And then we will have green, white, blue. These are two buttons, not three. Up. Up. So this. Start with white. Soldering iron. some solder wire. Doesn't look beautiful, but it's not a beauty contest. White, and let's leave enough wire. Yep, white is done. We said green on the left. Green is done, but it's shorting to white. So let's cut it. And then we have blue. Green, let's leave it as long. That's done. I'm sure we will need plenty of it. And we have that solder. Where's the blue? Blue. Blue. Let's cut the wire. Check. Okay, so we have this. The glue gun should be warm enough. Let's put it in place. So this comes back to the side. This should somehow... Oh, should it come back to the from the bottom? It should be able to come from the side. It did come from the side originally. Yeah, there's no space. So let's fit it in. Okay, so it should fit in this way. So let's put glue. Might have a mess happening here. Yeah. Let's wait until glue go. This is just 2 points just to tack it. Still you put 2 points also on the top. One, two. This is too loud. Top button still works. Button works. Yep. It's not ideal, but it works. That's need to put a lot more glue. Also, something is not springing back correctly. No, let's go. It's okay. But I need to put a lot more glue because it's not holding when I press on the button. So let's put glue liberally. I could put the wire through the button instead of through the side. Let's do it while it's warm. Okay. Okay, that's the one side. Let's put the controller on the other side. This, we need to put it this way. So we need to cut all this plastic. And we also don't have this pill anymore, so we can cut it. Up, up. Sure, this is not enough, but we'll try it. We have to remove these pins. Up. Do they? Yeah, they skimped on soldering these buttons. These are just. Yeah, you don't need to. See, they didn't solder all the buttons. Let's also clean it. I don't like seeing flux residue everywhere. Let's put some alcohol and just remove most of it. Not the right thing. Okay. Up, up, up. So this part is clean. Let's put the glue gun. Oh, it's not in the way. Here. Let's remove this connector so we have more space. If we want to, we can now. Wish I wouldn't want to cut the board. Does it fit now? Actually, it does. You have to cut these things a bit. Let's remove them. Ah, sorry. It's at a view angle. Yeah. Up. This. Even more space than I would ever want to. goes even through, but then I cannot move it. So I removed too much plastic. Not an issue. Let's try, I have an idea. How can I glue it so it holds in space? I will need to glue the front first, and then the back. That's the center. Let's glue it from the front. We will remove the glue from the front. But at least it would hold it well enough so I can glue it on the back. Sorry. Let's wait until it cools. Actually, I have a fan dedicated for these tasks. Okay, let's try to glue it now. Put some glue everywhere so it holds. It won't be rigid at all. Not sure we'll be able to press the buttons. Up, let's get the fan. Where is the fan? Now I remember what I wanted to do. Let's get the fan so it cools down a lot faster. volts. I have 12 volts here. Other way around. This way. Oops. Okay. There is some glue which dripped inside. So that's not good. Let's remove it. Luckily, hot glue is easy to remove, just with a bit of alcohol. And up. Almost gone. Up. Now it's gone. Okay, second try. First want it to hold a tiny bit, and then I will put a lot more support. So this is part 1 of the controller. Where is part 2? This we don't care anymore. Actually, we don't care. We can still use it. I mean, it's I2C. So if we want a joystick with motion control, the protocol is known. So, and the wire is almost broken. So we could keep this for another project and just have a joystick with motion control, and can still put the 2 buttons. Oh, buttons, yeah. So let's keep this. Assembly. Okay, this seems solid enough. Yep, good enough on this side. Let's put it on this side now. Put a bit of cover and have it drip. Up there, I think in the end, it's probably easier to design a board. I would have to look if the protocol has been reverse engineered for the joycon, but it's probably easier to design your own case and your own thing because this is not rigid. As proof of concept is fun, as final product probably not. But yep, as proof of concept we could, so now it's holding and we will have the joystick ready once it's glued. We need to put a lot more glue for rigidity because we should be able to press on this button. And if there's not enough glue, we won't be able to. But for now, we just want to test to have it cool down. So fan, cool down. Up the alcohol, the battery goes here. So the second part of the board is here. Let's not break it. Up, up, while it cools down. Does this still work? Yep. We have the 2 buttons, the wires with it, and we have plenty of space. We can even remove these things because they will probably be in the way of the controller. So this part, it fits. We have to wait until this is done. But this part fits. This we can trim a lot more. You can see all this we can remove, all this we can remove, all this we can remove, and even this part we can remove because these 2 buttons are not important anymore. Not sure what R1 and R2 are, but we'll find out. I'm not even sure what's top and bottom. Is it written on the remote? No, it's not just ZR. I think R2 is the bottom one. Yeah, R2 is the bottom one. R2 is ZR. And so let's write it down. R2 is equal to Z is equal to ZR, and we have, where is it? Here. Yeah, I don't know what this, so this is, so one is, the middle is, so white is Z. This should be ZR. Then we have C. I don't know if it's, but G is ground, so green is ground. Yeah, G is ground. The pinout is not exactly the same. That's fine, we have wires. If it doesn't work correctly, we can still inverse it. What will be a lot of work is all these traces. How many are there? Plenty. That will be a lot of work. Do I have a ribbon cable so I don't need to? Let's see. We still don't know if it will work. I mean, we just cut the thing apart, but we don't know if this is working correctly. So here, can we put this back on without interfering with the board on the bottom? So the wires go down. Ah, I didn't count on that. Okay, the glue is in the way of the buttons on the top. This doesn't fit anymore. And but I need to stabilize it. I can stabilize it on the side so I can remove the buttons. So let's first try out if this works. If the joystick still works. If the joystick still works, we will just reinforce it from the side and not from the top. So let's remove this hot glue. So let's put a bit of alcohol and let's wait a couple of seconds up until it, okay, up. So yep, it works. We can see we can see the potentiometers, but the joystick works. That's weird, but once you have it in the hand, it's pretty fine. We need to remove this glue, so we need to put glue on the side because this glue is interfering with the glue on top here. Let's create a bridge on the side. Up. That's one side. Let the air cool this down. So that will be one side. This will, so we need the antenna. We can shorten the antenna though. Let's not break it, but sure we can shorten it a tiny bit. Up. Ah, you don't see what I'm doing. The camera is not in the ideal angle. This is what you should see. Or maybe I just forwarded. So I just cut the piece here so I have more space with the antenna. This could fit pretty well. A bit anywhere. That's the one side. This can be trimmed a lot. Let's remove this connector. Oh, I didn't unsole it completely. Ah, good enough. Ah, the ground. Like always the ground. But we have... Don't we have the buttons? Yeah, here. We can also cut this part because the trays are going to K1, this is R1, and KR2, this is R2. So we can also cut this and just solder on the pins. Let's do that. Up. This saved some corner space. Did I break something? No. No, this is just a connector. On this side, this is the home button, or the plus button. The plus button goes to... So let's write it down. R1 and R2 are going to K. R2 is equal to right, which is C. Then we have this goes to KR1, probably key, like keyboard, and those goes to KR1. Now, key 9 is the plus button. It's just this button here. This is plus. We can cut all of this. Yes, we can. Yeah. Up. We can cut all of this. We can also cut off this. Yep. This is shorter. We can cut this off. Oh, that's K8. K8 is plus. K8 is equal to plus. Okay, a lot smaller now, huh? This is done. Does this still work? No. There is a bit which went to the side. Damn it. I didn't pay enough attention. Come on, glue. I need to cut the glue first. So I just take away the faulty part. Let's put some alcohol again and let's remove this piece of glue. Come on. Okay, the culprit is gone. Now I can move this joystick freely. Oh, I can even press on it and it holds, but I will put a lot more glue. And first let's have a look if now we can close it. We needed to remove the top glue. So for that we need to put more glue on the side to have a more rigid structure. Up. And I'm also not that good in, so why didn't I design it myself? I could, but it would be a good exercise. I don't know how to use CAD software or mechanical CAD software. Up. Oh, damn it. Don't go too much on the side, else I won't be able to close the case again. Up. Yep, you have to go. I need this space to close the case. This I don't need, it's just too loud. Up. And I think if I design my own, I would design a driftless stick with Hall effect sensors. That might be a good exercise. to learn how to do 3D and then to learn how to joystick. But then I don't want to reverse the joycon protocol. If it's been reversed or if there's already some code, that would be nice. Something like for an ESP32, which has Bluetooth. If this could emulate the joycon, that would be ideal. Then I would be ready to do my own design. Well, we don't know how long the Switch will live, but the joystick would still be quite nice because it could be, if it's programmable over USB, it could be programmable for everyone, for every other control. So for now it would be only for the Switch, but it could be adapted to any other controller if we program it ourselves. This is only capable for the Switch. So we wanted to remove this glue. We want to first put it on the other side also. Let's cool it down. You're in the way. So keep it here. I don't want you in the way of the motion. Afterwards we can clean up by reheating everything reheating with the hot air gun. So let's remove this because this will not fit. I was wondering why my finger is now black, but I just touched the IPA writing. And I can clean it off with some IPA. So I just I have to use IPA to remove some IPA. Okay, can I still use it? And yes, I need to remove this bit. That's doable. Up. Yep, that works. Is it still click? No, it's not clickable. For that, I would need to put some bridge here. This in the way. It's almost clickable. Can I now close it? That was the whole purpose. Okay, can I now close? Or is some other side in the way? Come on. This is in the way. Let's remove this for now. The other one was sticking a lot further down. Don't tell me that there's not enough space. Okay, with brute force, it kind of fits. Okay. Ah, it's pressing. Something is pressing. So there's not enough space. Do I really need to cut? What is press? Where is it pressing? On the top or on the bottom? Can't be on the top. It's really made tight. I think designing a controller is probably not the worst. Designing the case is not the worst idea. Ooh. Maybe all this glue is just too much. Maybe I just have to fix it here. And it's big enough. And it's large enough. That would be nice. Let's try it out. So let's remove this. All this glue for nothing. Maybe it fits really nicely on the bottom there. Up. Here's some remaining glue we could remove. Let's also put lots of IPA here so we can remove it. Up, 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 all removed. Here too. And removed. And the IPA can just vaporize. Vaporize. I think it's evaporate. Okay, this goes here. This we don't need. It's solder we don't need for now. What if I just put it in here? Actually, could make it fit. We need to trim the sides or to remove some glue. Does it fit? It should fit. We just have to remove glue. Okay, let's see if it does fit. Okay, it doesn't fit complete. No. We have to trim off a bit. It doesn't fit completely. Let's use a file. This is barbaric work. Up. Do they have different? No, it's the same on both sides. Is this enough? I'm not sure. I a whole lot. I made it clean, but I don't think I took a whole lot of away. Oh no, I did. It's not enough, but it works. This side needs more. Let's try again. Yeah, now it slides almost perfectly in. It would be awesome if this would fit. Oh, it doesn't. Oh, all this work. No, almost. No, but it's too low. Still, if we could fit it in here and hold it in here, so we just have to press this on, that would be nice. I know what I could use. I need to find it. I have some molding. Some glue tack, although it's yellow. We can use that to tack things in place. Up, would this work? What if I tack you in place and then cover you with glue? Oh, there's not a lot of space. Let's see. Nah. Okay, it was just an idea, but it doesn't really work. What if I tack you here on the side? No, it's not. Doesn't really work. What is this plastic? Let's remove this piece of plastic. Destroying everything. Up. If I now press here, is this the right height? Then if I would just lift it up, maybe it works. Here, and let's try with the blue tack again. It doesn't hold shit. Okay. It's not bad actually. Somewhere around here. Could work. I close it. Let's try something. Okay. What if I just hold it? I put some glue inside, and while it's warm, while I hold this, I slide it in. Let's try that. So, let's put some glue. Somewhere here. Okay, I just eh, eh. What I should have used is the original one, but the original doesn't have a click. And this is not high enough. It's almost perfect, but it is not. So let's remove this glue. The idea is not bad though. We don't need this. Up. Let's remove the glue. Yep, not sure how hard it is to design a case, but might be a good solution. Design my own case. Particularly if I want to do a second one, and the second one is not the same fit. What if I just glue a tiny bit here on the inside? Yep, I think that could work. So let's do this again, and I glue first from the outside just to have some support. It's not centered. Okay, this is centered. Let's wait until the glue dries. Well, the plastic, the hot glue. And let's try. Okay, first let's try to see, does it fit in the case? Let's here, this is getting annoying. Let's put some tape on it so it's not in the way. Up. Up. Okay. Let's see if this can work. Should be able to. It is closing. Let's open it again and let's try to glue somehow to have some support on the inside. I don't know how to do that. I have an idea. Now let's glue completely. Let's put some glue this, clip it in, remove the glue and see if it sticks inside. That might be an idea. So let's put some glue here. Let's hope it sticks somewhere. Let's put some glue everywhere here. Let's close the case. Case is closed. And let's see if it glues somewhere. That might be a good idea. We have to wait because the air cannot go inside. Let's do it this way so it flows down. And we have to wait. What can we do meanwhile? We can try to prepare traces for all these traces. Let's do that. Before I prepare traces, I want to see if it fits inside, because if it doesn't fit, I don't want to do it. We can leave this inside. Doesn't, yeah, inside would probably be a good idea. I should have put some test glue somewhere so I know if it's done or not. Okay, the blue tack didn't work. Let's put it back where it belongs. But it was worth a shot. Up, up, up. This was here. Let's, meanwhile, let's prepare the traces. I want to do something up. So we just scrape the solder mask. Oh, actually, we should rather do it in the vias because we have lots more. Yeah, we should do it in the vias instead of on the traces. Yep, we have plenty more copper. You're not seeing what I'm doing. This camera. Let me move the camera. Okay. Now you see what I'm doing. The camera is a bit tilted, but at least you are seeing. So now I'm just removing the solder mask so I have access to the vias where I will put wires. And the remaining ones are up here. What's a pain will be to just have the traces. Okay, that's one side. On the other side, here we also have, oh, this is just a button. So we can directly tap there. That's good. So one technique is either to the vias, through the vias, or just on the traces. But on the traces, I always have the experience that they get ripped off and then it lifts the complete trace, which is a pain to repair. So for now, let's just try with the via. And where does this go here? That's the other side, and we need to do the same here. Although here they probably all of them go probably to test points, to the points. So we just have to figure out where do they go to. For that I will just expose the vias and then we can directly test. Yeah, most of them are correct connected. Just expose the vias. And then we will do some continuity testing. I'm sure most of them are directly connected to some pads on the other side. And these 4. Okay, with that this is done. Let's check the remote again. Something happened. Let me fix this. External display off, exit. Now you see me again. Okay, let's have a look. We have to remove this on the top, and if we can lift it without the joystick falling off, if we can lift the cover without the joystick falling, then we succeeded. Let's wait a tiny bit. Up. Okay. Let's open the case. It seems to be a winner. Yep, it is holding. It's not perfectly straight. It's not perfectly straight, but it's fine because we are. But it's holding, and I can almost even press. So this technique worked. Now we don't have a lot of space. We can solder the wires. I should have soldered the wires beforehand. I didn't do it. This will be hard now, but possible. Let's do it now. Let's get some wires and let's solder them. How many do I have? 1, 2, 3, 1, 2, 3, 6. Oof. Yep, I should have soldered them beforehand. Well, I can still do the trick. I know it works. So let's remove this. And actually I just have to reheat this and reseat it. Solder the wires. It's just for holding, so I can reheat it using the hot air gun. Reseat it. I would like it to. Straight, but right at this level. And this inclination. Yep, so we'll do it this way. Let's solder the wires for now. Soldering iron, wake up. You also want to see my soldering, although it's just soldering, it's probably not that interesting. Up. 1. I don't know what is what here, but we don't really care. We just need to connect them back there. So we just need to know which one is V, which one is ground. Ground is this one. That's the yellow one. So let's mark it. Where's the marker? This is definitely ground. Up, ground, ground. So we'll put it in black so we know which one is pin 1. I should have used black, but I didn't pay any attention. Up. So this is Rx. Does it make sense? Does it go through a trim? Yep, it goes through this one, which is right left. So this makes sense that this is Rx. This not being soldered bothers my OCD. So let's solder it. Sure, it doesn't provide that much more solidity, but at least my nerves are calm now. 2. So this is 30 AVG, and I can't show you what this is used for because it's used for pins. Here you can strip 30 single core wire AVG. On this side you can actually fix it on post. This is from I saw this tool by a telecom guy working in telecommunications. It's called, if you want it, VSU 30M. It is expensive, but it works really well. And the idea is that when you have headers, I can show it to you, actually. It's quite a nice tool. Let's prepare it with this one. So you use 30 gauge wire, AVG, which is single core. You put it in here, it goes through. When you see it through, put it this way, it is stripped. Then you slide it on top in this channel, and what's in this channel, you put it on a header and just turn it, and what it does is it turns it around the header. Let me zoom a tiny bit. It turns it around the header, and it's solid, so it's hard to remove because it goes from bottom to top. You can still solder it if you want to, but you don't have to. It's on there. So for putting wires on headers, it's a really nice tool. And yep, some things, it's expensive, but it's good. So I recommend it. So the next one, this way around. You see what I'm soldering? Let's put it here so I know this is the middle. This should be, this says it's R3, so this should be the clicky switch. Is the clicky switch? It goes right here, and this is the clicky switch. So it makes sense. This is right for now. Up, and we restart with green. Let's have some green. Oh, we only need 2 more. We only have 5. Then I should use the right colors. Yeah, I have 2 other colors. Although it's not the right colors, but we can make it the right colors. We will fix it and make it the right colors. So this should be VCC. VCC is red. Let's take some red. Now everything makes sense. Up, up. red. Single core, single stranded. Up. Red. Let's get it here. It's too long, but at least I have some margin. The black one will become the green one, so this, we remove it, we place it on this side. We will verify what's this side also. So the green one should be Rx, R epsilon, Ry, and that's the case because it goes through this trim pot, potentiometer, and this potentiometer is, actually it doesn't make sense. I know, Ry, yeah, so this potentiometer is top down, so this makes sense. Let's have the black one, which is now black and correct, so we have all the right colors. Oh, it's not. I have to remove the solder. Where's my pump? So before I can get the cable in. Black wire goes in there. Okay. Now we get this here. This is ready. Up. Let's get these cables out of the way. And now we need to put this back here. So we will use the heat gun. We don't need the soldering iron. Let's remove it. We don't need the desoldering gun. Let's put it on the trash pile. This is getting warm. So now I'm heating up the glue. Starting to melt. Let's put this one in. And it's almost holding. And the rest I can put glue. So hot gun away. And if I put more glue here, which is warm, it will also melt up at the bottom. And this should hold fine. Up. And theoretically, up. Once this is hard, we will also need to, let's have it harden out. We will try to close it, see if it works. You don't need up. Now it's just cooling the plastic again, the glue. These pads, let me get some 0-1 wire. 0-2 should also make 0-1 should do the job. These are just, let's use 0-2. It's less prone to breaking. So it's just 0-2 millimeter anima wire, magnet wire, however you want it. Wire which is insulated on the outside. This is why you see the orange. So this is almost solid. Let's put some tape. Everything on the side. Tape. Scissors. Yep. Tape. Okay, so they're not in the way. This is good enough. Let's see if we can close it and it still works. That's not ideal. Should be a bit further up. A lot this way. It's not centered. What we can still do is heat it up from the outside and let's see if it works without melting the plastic. Let's put 200 degrees. Oh, it wasn't probably a good idea. I didn't budge at all. So we will try to do it this way. We can heat it up more. 250, 270. Okay, now it's trying to melt. Let's lift it up. Oh, shit. This way. Let's see if this is better. Oh, better. Fixed. See, this is nice. This holds. Now, can we put this board in there? There's place on the bottom, and my hope is that it would fit here. This would fit beneath it. Ah, the antenna is in the way. This can probably fit. Ooh. Can we cut this more? Yes, we can. A lot. Yeah, we don't need so much ground. Okay. Ground is cut. Let's see. So this would fit there on the bottom. Can we? That's good. And way up is good. So the electronics on the bottom, the pads we don't need. No, it's easier the other way around because I can solder the cable. I will solder anyways. So this board fits in here. Now we just need to fit this board, and almost. This doesn't fit this corner. These two buttons, one is home. We need home, but I don't use that often. I also don't have enough button. We could still use home, but afterwards. This we should be able to cut. This is why do we have this decoupling capacitor? Because it's not VCC. Why do we have a decoupling capacitor on RY? This decoupling capacitor. I would like to remove this completely. Yeah, I can put this just to ground. Yeah, I can put this capacitor on this side. But I don't want to break everything without figure out where the wires go. I still need to solder everything on the pads. Let's try to figure out where each of the wires go. And let's solder the wires together using this one. So we need to zoom. And we need to probe. Up. Up. Where's my probe ring? Makes beep beep. Makes beep beep. So, and then we can even try, before we put it in, we can try if it still works. Because if we provide 5 volts, or if we provide the battery, there should be enough. It should be able to connect. Up. So one after the other. This is VCC. So we can directly solder to VCC. And then it goes to, I don't remember how it was. I think it was, wait. Here. This is VCC, this here is VCC. Can we, so I didn't scrub it off. But is this the same VCC as the VCC pad which is written? So here is a VCC pad. Is it the same? One side. Oh, damn it. And VCC is under my finger. Right, it is. Yeah, it is. So we can directly connect VCC here to VCC there. Let's do that. Let's do one wire after another. Up, soldering iron, wake up, heat up. Come on, heat. Faster. So it's ideal that they have test points everywhere. VCC, so up, prepare the wire. You're probably not seeing what I'm doing. Up. Prepare the wire. VCC. We don't know how this will go along. This I probably don't need anymore for now. Up. VCC. Let's have it long enough so we can. It does give a bit of resistance, but it's not a lot of power going through. Up. So you have a better overview of what I'm doing. This goes here. Let me Give me a bit of space to work. Up. We can put it to this VCC because it's the same, although we didn't solder the wire on there yet. That's VCC. The next one, this one, does it have a pad? It goes here, here, it probably has one. So this is one side. Let's try which pad goes on the other side. Where is my multimeter? Here. I'm not making any contact. Because it's not going through the wire. Let's strip it a bit more. Actually directly, do I want to solder directly on there? Yeah. I will. So 0.2mm wire. Okay. Let's try to solder on this thing. Okay, it's on the trace, and we need to find out where it goes. Let's cut a random length. For now, there will be plenty of wires going everywhere. So this is, wait, it goes this way. So this is this one. Where does this one go? Ah, this is SCL. That's the second one. Right, and probably the other one is SDA. So this is I2C. And this is very probably for the motion control. So SDA. No, did I say SDA or SCL? I don't remember. Let's probe it again. This one is SCL. So let's remove the copper. It's already done. It's already done. Did I do that? SCL. Ah, here we have two wires. The next one is very probably since the third one, it's probably SDA. That would be my guess. Damn it. It's really not easy to probe on both sides at the same time. Ah, this cable is annoying. Let's remove it for now. We can still put it back afterwards. Up, let me get something to hold it. a lot of test points. Okay. We are probing this one, and I say it's SDA. And it is SDA. So on this board, don't we have SDA here? No, we don't. RxTX, so we could actually see. I think also it makes sense that there's only one pad for SDA, which is on one side. So let's solder a wire to it. Let's get out of my way. Let's put this. Actually, what makes a lot more sense is just making a case where this slides in. That would be easier. Well, we started this project, let's finish it. Okay, that's this wire. Up. Yeah, so it's not completely left-right agnostic, but if you could switch actually in the switch left and right the joycons, then it would be a perfect. But I don't know if you can. Oh, SDA doesn't look good. I want it to be a bit cleaner. Okay. That's SDA, that's the third one. We still have nine to go. And that's only one side. Then we have something around 3 on the other side. So the third one goes completely up. So let's solder the third one. No, it's not completely up. Where does the third one go? No, it does. It's this one. It's this line. So let's solder on it. Let's prepare the wire. Are you not seeing what I'm doing? Yeah. Could prepare all the wires actually. Let's put it on this way. Up. See, left, right. It's good to be able to do both. I'm not as good with my right hand or as precise, but I can manage to do it. Up. Maybe a bit short. No, it should be plenty sufficient. So probably the other thing is not an I/O expander because most of the traces go directly. I need a finer tweezer. Up. Next one. Damn it. This is what I was afraid of. I need a finer tip because now the vias are so close that when I touch one, I also touch the other. Let's use a finer tip. That's doable. Up. Old tip, fine tip. Up. Let's put salt on the vias. On this one I need to go in temperature because the tip is not as warm as it expects to. Okay. So next wire. Okay. Once it works, I will put a piece of glue on all the wires so they don't break that easily or they don't rip off that easily. But for now, we need a proof of concept if all the connections work. Okay, this looks fine. Up. Only one wire on top, and then there are three. Is this not ground? Where is ground actually? Ah, on the other side. Up. So ground, not ground, but nah, damn it. This one is on. You don't see it, but it's, can you? No, it's just very fine work. Cut the wire. Coating removed. Now we have 4 more. Actually, no, 3. I think this one is one I soldered here. 3 more for this side. On the other side, we have 4 cables plus ground, but ground is easy. So 3 here. Okay. Let's wet the sponge. It's getting dry. One. It's plenty of wires. I even at some, yeah, I still think I still have it. I did solder some eMMC, surface mount eMMC, BGA surface mount eMMC. I soldered most of the wires by hand. This was a lot of work, and it was before I had an adapter. It does look nice though. Almost a piece of art I could put on a wall. And this is when I was implementing my own eMMC reader, because I had a device which used eMMC but which uses secret message of secret structure of eMMC. It did hide some data where it's not the main memory, it was some auxiliary memory, and with normal readers you couldn't read it out. So yeah, eMMC has plenty of various commands. Well, actually, isn't the Switch using eMMC for their cartridges? I don't know. I wouldn't be surprised. Custom eMMC, obviously, because they need their own crypto, so nobody can copy the games and then resell them. I mean, do they still make money out of the games and cartridges, or do they make money out of Nintendo Direct? And monthly fees? No, I think some games which are sold by million, they make still a lot of money with it. But Microsoft, is it Microsoft? Maybe probably they both have it with their store where you can play unlimited games. I think that's the model that's going to last. So next we want this pad, so we need to figure out which this one is. It's this one. Which bed is this one? It's this one. So the third is this one. After STA, the third, this is the third. And it's number 4, number 2. Let's try it again. I think it's number 4. Yep, number 4. So let's solder the third wire to number 4. And the third wire is this one. This is number 4. Next one is probably just next to it, probably number 2. Let's try it out. And this is where sharp probes is important. No, but it's just below number 4. And from a routing perspective, it makes sense. Up. And yeah, so the multimeter is not that important. Well, they're all good enough now. Having sharp probes is important. You can have a $25 multimeter, which is fine enough, which is very good, but you need at least $10 probes to have something for fine work, at least. For big dip things and so on, you don't need sharp probes, but for things like that, for example, you need. So next one. This is probably number 2. Yep, and the next one is probably the one below. Yep. So number 2. So this is number 2, and probably the other one is number 1. I don't know to what button it refers to. So this is number 2. Up. Did I mix something? Yep. This is not number 2, this is number 1. This flat layer here, this is number 2, right? Yep, this is number 2. Okay. This was not soldered correctly. Ah, this is because I didn't remove the coating. Yeah. The last one. There are only 4 here. Then there is something wrong, because then I only have. Okay. Oh, I still have one here. Just going like that. Ah, this is the big wire. Okay. So we have 1, 2, 3, then the big wire. Is that what we are remaining? 1, 2, 3, and the big wire. Yep, but I need to scrape off this one. Probably just a button. This is a surgical scalpel, so you can remove these blades and they're very sharp. That's what's useful. So they get used a lot, but for that they're very sharp. So this is number 3. So this is the last one. Number 3 is this one. Let's see where this one goes. Huh. It doesn't go to a pad. At least not one I can probe. Oh, maybe I didn't remove the copper good enough. And it doesn't make contact. Okay, now the copper is well removed. Let's clean the tips up. Alcohol up. And let's clean the tips. Okay. If we don't see on the pads, we can still solder on the via. This is going to a capacitor. Is it ground? No, it's not ground. But okay, it's going to this capacitor. Okay, let's also solder it to this capacitor. That's the third one. Yeah, and the third one is this one. No, it's not. It's this one. This tiny wire, yeah, it's the third one. 1, 2, 3, exactly. So this goes to the capacitor. That's large enough. It's completely doable. Let's put it above here. Let's go all around here. That's the capacitor. Can I go below it? Yeah. Heat up. Okay. Oh, that's not solid. I need to put blob, maybe it's pretty sure it's solder, it's lead free. Okay, yeah, it didn't hold. And my soldering iron was not hot enough for lead free. So let's put a tiny bit of lead solder and let's resolder the wire on there. A lot better. This is holding strong. So, second, it's this one. This one. Oh, it's probably to one of the pads. Let's probe it. And let's see. It's this one. Yep. It's RX and the other one is probably TX. TX. So there is serial communication. We could tap on it and could try to simulate it, but nah. Meh. So RX and TX. This one is RX. Let's put some solder on the pads. RX. TX. This is RX. The length of the wire not matching is not really an issue. We are not having high-speed data here. Impedance is also not important. It's just a controller. TX. And the last one is probably, this is the big one, and I think this is VCC. No, it's not VCC, but it's, what is it? It's this big button probably, so let's test it out. That's the fat trace. And it's VDD. This is VDD. Ah, the sun coming out. Wow. Oh, it's overcasting. I can't do anything. I don't have any blinds for this window. But it won't be there for long. VDD. VDD. So that's one side. On the other side, we only have 1, 2, 3, 4, 5. 5 of them. Completely doable. Where are they going to? So normally, here they are, the 5. Well, there's one large, exactly. So let's do the same trick. It's only 5. Let's scrape the solder marks so we can probe the pads. Okay. 1, 2, 3, 4. Ah, fifth one. This one. Okay, 5. And here, do we want to solder also inside 1? Yeah, we will do. Let's do it. Up. Let's put some solder here. This is, yeah, this one. Solder is not really sticking. I think it didn't. Ah, now it is. One. This must be longer. Let's prepare the other side directly. Up. Next one, number 2. Where is number 2? This is the large one. The large one goes here. Let's put some solder on the here. Okay, let's get the wire. Okay. This is probably the battery, or maybe VDD is the battery, because we had VCC. VDD is maybe the battery. Number 3 is this one. It seems that, wait, there's something weird. Where is this one going? Oh, this is something else. I need to probe this trace. Let's expose the trace so I'm sure that this is the right view. Up. That's the right one. That's this one, and this one, is it this one? No, it's this one, right? Yeah, it's the button. It's the home button. The home button? Why is the home button going from this board to this board? This is really maybe a shift register. I don't know. To read all the buttons, it makes sense, so you don't use a lot of GPIOs, but only 3 GPIOs for all the click buttons at least. That's how I would do it. Or because you want tiny microcontroller like the other one which don't have a lot of pins, and you can read them using SPI really fast. I think that's probably also, I don't know. I didn't have the Famicom NES controller, but I played it and so it had 4, 5, 6, 7, 8 buttons. It had 8 buttons, but I'm sure the controller didn't have the controller, how is it called, the connector didn't have 8 buttons. I think he had something around 5. So that's also probably what they're doing. They're using a shift register. It makes the why is it not sticking? It makes the controller so you don't have a microcontroller in the controller, which was at that time expensive and rare. And you can still read all the buttons fast enough. They probably don't read it at 10 megahertz, and also 10 meg because they don't have a microcontroller which is running at 10 megahertz. But up. So that's this one, and the last one is the home button. But you don't need to. Humans are very slow. Reading it at 1 kilohertz is fast enough. But I would be interested to know if it's really shift register. It probably is, and at what speed they're reading it. They would be reading it. The last wire will be ground, but for ground I will use a black wire. It is more important. Okay, let's put this way. Are you still seeing what I'm doing? Yeah. This is the home button. Let's use the pad. This goes to the pad. Okay. Up. Up. Now we need to figure out which button went where. So again, we will probe the vias, and I'm sure we will find the corresponding pads. So the first via is this one. This one is no pads for it. This is still working. Well, we have the resistor which is not populated. Can use that. R64. This one, let's put some lead-based solder. Let's have it's this one. If it still works, if the controller works after this, I'm really happy. If it doesn't, then the project is killed. We'll have to debug it. R64. Next one is... No, it's not the right one. Oh, it is. It is. Next one is the large one. So the thing is getting a lot of wires now. This is the large one. The large one is... Come on. These are all the buttons. Well, we can use C4. C41. Can use the one side. Let's put some solder on it. Okay, it is this wire. Okay, two of them. The home button first it's not this one is done. No, it's this one. Oh, did I solder the wrong one? I think I did. Yep, I did. It's not the right one. This one should be it. Yep. We can test it. It's the thick trace. Thick trace. Yep. Next one. Only two remainings plus ground. And one of them broke. Which one is this one? One of them just got removed. Ah, here. Okay. So it is... I'm sure this one has... I hope this one has a pad. It's sys reset. Okay. Sys resets, and I'm sure the other one is just the one next to it. The home button. It's not this one, it's this one. There's starting to be a lot of wires. Sys reset. Okay. And the last one. Up. Yeah, I'm pretty sure it's this pad. Here it's written even home, and then we know it's the home button. Yeah, it is. Alright, this is the home button, it makes sense, and this goes here. So let's put some solder on the pad. And let's put the wire on it. Now we just have to connect ground using a black wire. And so ground. It's just AVG30, but it should be good enough. Do we have a ground point here? No, but we have ground right there. We can use this one, and we will. Ground, and here I know we have a ground wire. Da, 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 da. A ground wire, a ground pad. Oh, I didn't even cut a pad. Don't remember what this pad is. And there was one button, the plus button. Ah, but it was written plus. Where was the plus button? It was on this side, and it was this one. Yeah, it's the pad which just broke. If we want a plus button, we need to put the plus button on the other side. So we need a ground pad. I did see ground here. Ground is connected. So with that, the two boards are connected, and we can even test it. So this is the indication status bar, and this was going in here. If everything works, I will cover all the pads with glue. But for now, let's test if it works. Okay, this was the pad. Then on the other side, we had the SDA, or how is it called? The Wii controller. This is stupid. Maybe I don't know what it's doing. On the other side, we had this thing, this bar. Actually, we can try it. We don't need to. We just need to the switch, and we need some battery, and that's it. So let's switch on the switch. So I can check if it connects. I don't know if all the button works, but so power, I didn't even check. It doesn't get warm. It switches on the switch. Oop, the fan just come on, switch. Let's press the home button. Okay, there is. The status LED says something. Probably something. This is probably an error code. Let's press the reset button. Okay. It's not changing. So this is not a reset button, this is something else. What doesn't it like? Let's try again. Okay. It gets power, but it's not able to do anything. There might be a loose wire, or I didn't solder everything correctly, but for now, or maybe this just says I'm not synced. No, I don't think so. I really think this is a debug code, this pattern. Maybe I put this in wrong. No, it was a tab. Ah, the connection is quite loose. Oh, because this is not closed, but if it's closed, yeah. Very probably an error code. So, where is the error? Is one wire gone? Would be awesome to have how is it called? Reference board. The motor, is it complaining because the motor is not there? No, it did work without the motor, right? Let's put it back. Let's see if it's that. I don't think that's the issue. Let's put that the motor. We will see if it's that. Battery is not there anymore. Heat up. No, I don't. Nah, that's not that. That's something else. But it says always the same thing. So, which one is it that's wrong? Or which one is it that's not correctly connected? Okay, I know how we will do it. We will scrape these pads off, and on the other side, and if they're all connected, so it should be this way. If they're connected correctly, then we should have continuity between both of them. So let's do that. So let's up. That's one side. The other side is almost scraped, but not completely. This wire is not, and we do the same here. Did we connect this trace? Ah, this is probably VCC. We'll see. That's one side, and the other is here. After that, I need to change the blade of the scalpel. Okay, so let's probe the sides. So this is ground, is it? Okay. No, this wasn't ground. This is this pin. This worked, but this is ground. I think that's not supposed to be ground. Oh, maybe I broke off a bit more. But there's supposed to be this trace. It's a thick trace. Okay, there is a short between these two. That shouldn't be. Between VDD and ground. No, which wire is it? I should have used colors. No, I don't know which wire is which. And one broke off. Damn it. Oh, this is the home button, right? Yeah, this is the home button. That's easy to fix. Heat up. But there is a short. Okay. So I will draw what the path are. I'll draw, or at least write it down. Up. Where is my pencil? Here. This on the complete left should be. Was it VCC? Was it VDT? This one. It's connected to ground, but it shouldn't. Yeah, it's VDD. VDD connected to ground is not a good idea, right? VDD. How did I connect VDD to ground? Ah, probably here. Let's see if I unsolder this. Yeah, probably here. Let's see. Is VDD still connected to ground? Fixed it. Well, not completely. We'll see if it's also fixed here. We have ground here. No, it's not completely fixed. VDD is still connected to ground. But I see, yeah, it was here. Yeah, it was here. Now it should be fixed. Yeah. I see the error. Well, that's because I removed solder mask on the ground and it did connect to ground. And this is why you have solder mask. So traces don't connect to each other. So let's try to do this again without shorting it. Now it seems fine. And now VDD is probably not connected to ground anymore. No. And that's a good thing. So let's try again and let's see what lights it shows. I hope this battery, no, it doesn't have a protection circuit. Meh. Meh. Do I have this connector? Because if yes, I would just use my multimeter. Power supply. So, Dupont case, not Dupont, cables. I probably have it. This goes down. I have plenty of tiny wires. I wouldn't be surprised to have also one with two, like something like that. But something which is cut, so I don't have to cut it. Would be even better. No. It's a box full of them. I don't find the right one. This is far too large. Yeah, we'll cut this one. If it fits, if this fits, I will cut it. And this doesn't fit. It's smaller. Oh, it's teeny tiny. I'm not sure if I have that small. Let's check. Because this way I can see how much it draws. I can protect it against overcurrent because there was a short and I don't want to kill the battery, and the battery doesn't have a protection circuit built in. No, it doesn't. It doesn't seem to. But I don't find the right connector. Oh. I do. Ah, damn it. Ah, okay. No, I don't. Let's just try it again. So, else I could just solder wires. No, I can't. Oh, it's SMD. I can solder wires here. If it doesn't work now, I will solder wires because I want to protect the battery. Okay. No LEDs are on. And now if I press on home, which one was it? I think it's this. No, this is K. This is home. Oh, it scans and... Ah, damn it. Did it find it on the switch? Let's press home. Scanning. Yes! It works! And if I press on these buttons, It doesn't say anything. Ah, the controller has shut down. Maybe the battery is empty. But it does find it. Ah, I pressed. Normally I hear something when I press on a button, but here I don't hear anything. And we don't care about these two buttons. S and S right and S left. But it would be nice to test if the buttons work. Can I change search? Can I see somewhere the buttons? Ah, if I close. And they only work when it is recognized as how is it called? As one controller. So what we could do is use the 4 buttons, which I don't find. This is for something else. And press the rubber membrane. Where is the rubber membrane of the here? That's the rubber membrane, and we can press the buttons on this side. See if they make cling cling. Yes. It makes cling cling on the switch. It works. Yes. Okay. I need a tiny bit of pause. Oh, it's already 4 hours long. I need a pause. I need to drink something and I need to pee. But I'll be back soon. Intermission. Okay, I'm back. I didn't drink though. I just got the water. Okay, now I drink. The switch works. The switch works. The controller works. Can I put it? Now the question is, oh, I want to cover it. I want to cover the points. Not all the points, because I still need to, for example, to connect some wires on the buttons. A, B, C, D. These buttons. I need to put, oh, although could we put this right here and have the buttons? Oh no, no, I'll put some buttons. So A, B, C, D, we don't want to cover, but all the rest we want to cover. Can we? I don't want to rip them. Although this we don't care. This side we care. This side is a lot more fragile. So what is this? This is UV curing resin. UV curing resin. And the idea behind it is that it's first liquid, and like with SLA printers, it gets solid when it's under UV. So I just need a UV lamp. I don't want to use this. Up. Here is a UV lamp. Here, multiple UV lamp. I think it's 1 watt, something like that. Oh, 3 watts. Okay, that's fine. And now we will cover the soldering points once they're flat. Does this still work? Is there some liquid? Yeah, there is some liquid. Let's get the first part off. Maybe it's old. Here. Here. Oh, let's get this first cured. With that, it should hold. On this side, I can solder on the pad, so it's not important. This side is a lot more fragile. Stay down. And that's all, I think. And you see, even this strand got rigid just by the UV light. It's cute. Let's leave it here and cut it afterwards, just to see how well it is cured. And yeah, I think, I don't know what it's called. It's just UV curing resin. You find plenty of it. Cannot use it as glue though. So there is also UV curing glue. This is just resin. And afterwards, once it is cured, it should make a solid. So it should be like plastic. It's not completely solid, but it should hold most of it. And I'm not sure if you see it, but here is, you see? Here's a hook now. It's almost solid. Yep. So this is solid. This is solid. Now let's cure this. With 3 watts of UV, it's cured really fast. This is solid. And it's also, I think this is UV 365 nanometers. It's not the 405 or 316, 395, which you generally find with UV lights. So this cures a bit better. This is cured, so it holds. That's good. Now we need to find a place to put it. And this is kind of solid, kind of. Yeah, we need a place to find it. And then we can put these wires, and then we also need the, so this is the right controller. on the right controller, they are A, B, C, D, is it? On the right controller, I don't very frequently use this. I use very frequently the buttons. So we need absolutely the buttons. And for the buttons, I will put 6mm buttons. I'll probably put them just under here. So if I have it in my hand, oh, I can unzoom. We're not soldering anymore. If I have it in my hand, I can still use this. And just below it, I have the 4 buttons just next to each other. And instead of having them, no, it's still important. No, it is not. So I thought we don't have to have it in a 4 points. We could have it one next to each other. Very often, so sometimes you press 2 buttons, but it's never 2 to the side. It's these 2 or these 2. So these 2 or these 2, but very rarely these 2. What we could do is have these 2 here and these 2 on this side. This 2 here and this 2 on this side. This is also a bit further away instead of having a 4 buttons pad here. Makes it weird, but makes it unusual, but it's no, it's else it's a bit too low. So here it's fine. Still, here it's pleasant enough. How do I want to put them? Oh, okay, the red is just a cover. You could have something else. This one is still searching. This is completely going bonkers. The other one. 1, 2, 3, 4. How do we want to put them? Do we want to put them in a cross? Or do we want to put 2 here and 2 here? Because I need to put them. Now let's check if I have enough space to actually hide these 2 boards. Probably yes. Yes. I think so. This we don't need anymore. We should keep it inside in case we still have an issue. This could go inside here like this. There's enough space. Then we have the 4 wires, the 6 wires. These are the 6 wires. And here the 4 wires, which were here, are going to... I think I cut it off. I think it's this board. Yeah, I did cut it off. It's SR. It's these... where are they? There's SRSL. This is this one. And KR1, KR2. We also need to solder the buttons there. But can it fit? Will it fit? The battery can go... it's large. So if it fits, it should fit on the back. This... let's do it the other way around. Okay. Oh, the electronics on both sides. So this way was quite right actually. But this needs to go below it. And preferably the other way around. So this way. For now, let's remove this connector. Okay, this fits. This could even go a bit further down. Can I slide this one also below it? Yes, I can. This way. This should be able to go further in. What is blocking? Actually, I don't need to. I can just press it. Yeah, it's fine. See? It fits. Here we have the battery and the motor. I don't remember where the motor is. This motor, I could still have it long enough. And then we have the ABCDE cables, which are here. X, where's B? Also KR1 and KR2. And yeah, this does fit. I need to put some tape. So let's solder the wires. So let's solder the buttons. Not the yeah, still need the buttons, but the buttons are just below here, so they have enough space. So let's solder these wires. These are far too long. Where is the motor actually? Motor goes here. I can put it. I need to glue the motor or to put some tape on the motor and put the motor. I'll put it a bit further away. I will put it below somewhere here. So the cables are probably not long enough because it goes. Where does it go again? Motor. Here. It goes all the way back. Yeah, let's just make them longer. We have wires. We can make them longer. And we have teeny tiny shrink tubes. Up. Let's make them longer. And let's make the motors a thing. And let's make the buttons a thing also. We even have pretty colors. So, blue and red. Red. And blue and red. Isn't it awesome? Let's take care of the motors and then the buttons and so on. So we'll make all the buttons now. It's not a hard task, it's just must be done. Wake up. Up. Put the shrink tube first. Else I'll forget it and it won't fit in again. We can remove this stickers and we will put our own glue gun. We will glue it to the board. Up. Yeah, this should be long enough. Up. Solder wire. Dun, 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 dun. Solder wire. Okay. One. Let's heat it. Hot air. Okay, this trick tube was a bit too large. I will still hold. It's good enough. I need to fix, that's probably the next hack, quick hack I will do. I have a new soldering gun. I also gave mine away. And this new soldering gun I would like it when I put it back in the cradle, in the holding surface, that it stops heating, and it's easy to do with either reed switch or how is it called? Micro switch. Reed or micro switch. Probably use a micro switch, because with micro switch I can cut mains. Yeah. But that's the next quick hack. Probably next week. No, next week I want to do the kettle. So the week after it. Too many things to hack. And this is just part one of the joycon. I need the replacement for the left one, which is still blinking. Yeah, it is still blinking and trying to join. So this is completely going mad. And once I have the replacement part, I can also have the left joycon nunchuck, the joy nunchuck, nuncon. One. Two, let's solder the controller. Oh, let's solder the motor. So the motor is, where is this motor pad? I keep losing track. Here, motor. What we need to do is also put USB-C, a USB-C connector. So first this, and with the USB-C so it can charge. It would be nice to say it is charging. Yep. And the USB-C needs to go here. It has plenty of space, right? Yeah, that's good enough for USB-C. We'll put a USB-C here with 6 pins. We'll put lots of glue, so it holds with glue. And one after the other. The motor. Can we test the motor? If we switch it on, does it do anything? I would like to test one after the other. Can we test the vibration? Is there something to test vibration? This goes on, up, press the home button. If I don't have the home button on the controller, it's not too important. I don't use it very often. Okay, now it is connected. Back, it would be nice, maybe I would have plus. Plus is used in some games, so I will have 2 buttons. I will have plus here and home here. So I need these 2 buttons. Is there another button? Yeah, there's turbo, but turbo we don't need. So we will put 2 buttons which are not used very often, plus and home. We'll put them here on top. So we'll have 2 buttons, additional 2 buttons. I only have 6mm buttons, I think. No, for change grip close, change grip order. What's order? No, that's not it. Close. Where can I check the controllers or the vibration? I'm just looking at my switch now. Switch, TV output system, notification, controllers and sensors. Controller vibration on. It didn't vibrate. Should it vibrate? I switched it off actually. I didn't want vibration. Okay. More. Because the previous controller I had, the vibrations were far too strong. This is why I switched it off. Can I test the vibration? Calibrate motion sticks, touch sensitivity, calibrate motion control. No, test input device. Test input device? Test for controller buttons. The symbol for that you will press will appear. Oh. So if I press A, should it work with, where's the pad? Yeah. Yep. A, B, Y, X. Oh, that works. I want to test the vibration. I don't see why the vibration wouldn't work. But how do I test the vibration? Should I just start the game? Let's start the game. I can't use it with a touch. Now this is where home is important. Let's press home. Okay, I need the home button. I don't need a turbo button. This is cheating. How do I test vibration? Controllers. Maybe search for controller. Press L out. Press L on an eBay controller to make the selected controller WAP. It works. It just vibrated. I have. If you can search controllers. Something is going on. Okay. If you press here, this vibrates. You see even the thing vibrating. So the vibration works. That's good. This is done. So the next one is these two. Let's remove the battery. We know it works. Once I have all the buttons, I can go on with the USB charging. But now let's do the buttons. And I think these cables are far too long. Let's cut them here. They should be good enough. Yeah, that's good enough. Let's strip them. And let's connect them. So there is ground, K1 and K2, and which we'll have to figure out what is what. Green, we know that green is ground, that's for sure. And then we will just test. Actually, we can test now which one is which one. Multimeter, multimeter. Here we have the one wire, two wire. Let's have some alligator clips. Black should be green. Should be ground. Not sure if it holds. It doesn't hold. Yeah, okay. And we have red. We put it on the other one. And depending on what we press, it makes beep. No? No? Maybe because green is not connected. Come on. These croco clips are not very good. No. No. It's none of them. If it's not with this, it should be with white. So is white ground? No. Okay. One should work. Wow, none of them working. Do I not know how buttons work? No, really? Pressing the button and the Multimeter doesn't make beep. Is the multimeter working? The multimeter works. This works. Maybe it's just one of the buttons which don't. Ah, green, sorry. Green. Let's try with the other side. White, white. No. I did solder them. Did they break? Or is something else going on? Isn't that pressing? No, it is. It is pressing on the buttons. I don't want to remove everything. The glue is well. Why doesn't it work? Let's try with resistance. Ah, and now I know. These are pads. So continuity will not work. Let's try just with resistance. Let's go to the white one. Because these are carbon traces, they have some resistance. And I think the continuity is under 10 ohm, and maybe this has more than 10 ohms. So the white one, no, no. Okay, my assumption is wrong. check. Okay. So, sorry if you had some other noise. Let me check if I hear everything in the headphone. Ah, I don't know why. Maybe they auto switch off after 5 hours. I never had a stream which is 6 hours long. Am I getting a tiny bit tired also? I'll do 1 hour max more, but that will be it. I have some other things I need to do. And I'm losing concentration. So, up. Let's put a tiny bit of blob here. This glue should also be fine. It's too much. Thankfully, I have gloves. I was sure that I would have some on me. And this is what happened. I think this is quick, so we'll just put it below it. And is it quick or one? No. It doesn't say if it's quick, it just say it's plastic. It has acetone, so yeah, it melts a bit the plastic. That's fine. Danger, but it doesn't say how fast it glues. Yeah. Let's prepare the other buttons. We need 6 buttons. So A, B, X, Y, and home and plus. And I'll probably change them with better suited tactile dooms, not metal ones, but other ones. So we have time to prepare them and glue them. 1, 2. Tiny bit of glue. It rhymes. Up. Not too far away. Up. Check, check. Okay, the audio is dead. I need to use another headphone, but it's not long enough. Let me try to make this longer and to have audio. Yep, my wireless headphone just gave up. And it makes sense, it's not meant to. This is red. Okay, so I switched to wired ones because my wireless headset just gave up. It doesn't have any power anymore, so it's only meant for 4 to 5 hours, but not much longer, which is normally plenty fine. 4 to 5 hours. For now, I'll use the other headset. I'll have a different voice, and the cable is not long enough. Do I have another one? Let me just put the last button and then find another headset. Okay. So that's the last button, but I think the stream was long enough. I'll just end the stream. I'll still solder some wires for the AB buttons, but I won't spend too much time. I have other things to do. You still have a bit of time, not much more. Other things to do, but also no audio. You will see, I'll show in the stream afterwards another time the continuation of this part, and you can see better results. But for now, this is ended. We'll try, tomorrow. Let's meet tomorrow, and we will continue tomorrow with this thing. But for now, this is the end of the stream. 6 hours is plenty enough for now. So yeah, enjoy, and that's everything here. Bye bye.